All right, we're going to do 7.1, number 18. Now, usually when we do integration by parts, we want to look for something that we can take the derivative of that would get simpler. But this just keeps coming up with e to the 3x with times a constant. And this goes from cosine to sine to cosine to sine. So let's just go ahead and do it with u equal to e to the 3x and dv, the rest of this, cosine 4x dx. So if we take the derivative of this using the chain rule, we'll get 3 e to the 3x dx. And if we integrate this, the derivative of sine is cosine, so it would be sine of 4x, but the chain rule would create a 4. We don't have it, so we have to divide out the 4. So this would become uv, so that's 1/4 e to the 3x sine of 4x minus the integral of, so that's uv, we started with these two, so we go to the other two, so that would be 3f e to the 3x sine 4x dx. So we do uv again, and we're going to let u be the e to the 3x again, and the rest of this be the dv. So the derivative again would be 3e to the 3x dx. The integral of this would be 1/4 again, and it would be negative cosine 4x, because derivative of cosine is negative sine, so derivative of negative cosine would be plus sine. So this would become 1/4, this is this part, e to the 3x sine of 4x minus 3/4 integral, parenthesis, uv e minus 1/4 e to the 3x cosine 4x minus, and then we're going to have the ones we didn't create or start with. So that'd be a minus 3/4 integral of e to the 3x cosine 4x dx. Now, you might say, whoa, we're right back to what we started with. That looks exactly like this, except it's minus 3/4, and minus is actually plus. But we are not losing ground or spinning our wheels, because we can do this. We can simplify this, and then whatever this is, we can bring it over to this side. So now let's get this cleaned up a little bit. So we got 1/4 e to the 3x sine 4x minus 3/4 times 1/4 is plus 3/16 e to the 3x cosine 4x. And then these change sign, but then we got to take it times a negative 3/4. So this is going to be negative 9/16 integral of e to the 3x cosine 4x dx. And this is all equal to the integral of e to the 3x cosine 4x dx. So if I add 9/16 of this mess to this side, which has one of them, or 16/16, I would get 25/16 of what we were supposed to find. Is equal to just this, 1/4 e to the 3x sine 4x plus 3/16 e to the 3x cosine 4x plus a c, but I'm going to do it after I multiply both sides by 16/25, 16/25, and so these cancel out, and the integral that we were supposed to find, the original problem up there, is going to be (16/25) times 1/4 is 4/25 e to the 3x sine 4x. And 16/25 times 3/16 is plus 3/25 e to the 3x cosine 4x plus c. Okay, 25. So we're supposed to find the integral of this. Well, there's not much here. We got this and we got that. Now, we could let 1 be u and the rest of this be v, but letting 1 be u, the derivative would be 0, and that would kind of mess things up, and we'd get right back to what we have here. So I do not know how to integrate cosine inverse, but I do know how to take the derivative. In fact, we're trying to find out how to integrate it. So I'm going to let u be the cosine inverse of x, and dv to be just dx. And so integrating dx, I get x. And differentiating cosine inverse, I think that's negative 1 over the square root of 1 minus x squared dx. Okay, so this becomes uv x cosine inverse of x minus the integral. We started with these two, so we go with these two, and that would be x over the square root of 1 minus x squared dx, but there's a negative on this part right here, so that's going to change that to positive. And now to do this part, I'm going to let u be 1 minus x squared and do a simple substitution. So du would be minus 2x dx. So dx will be replaced with du over minus 2x. And then this would become x cosine inverse of x plus the integral of x over square root of u du over minus 2x. The x's cancel, but the minus 2 comes out as a minus a half, so I have x cosine inverse of x minus 1/2 the integral of u to the minus 1/2, because that's in the denominator, du. So now I'm going to integrate this. So that would become x cosine inverse of x minus 1/2. And raising this by 1 would make it u to the 1/2 times 2 over 1 plus c. So that becomes x cosine inverse of x. The 2's cancel, the 1/2 and the 2 cancel, makes it minus, and u was at 1, and this is square root of u, so it's the square root of 1 minus x squared plus c. Okay, so now we'll go to this one. And we have another one where it doesn't get simpler. It's cyclical like we did in 18. So, but some of you didn't know how to differentiate or integrate 3 to the x. You know how to do e to the x, but not 3 to the x. Okay, so you have to remember or look up the rules. If I let u be 3 to the x, the derivative is ln 3 times 3 to the x dx. It just produces an extra ln of whatever the base is. So v would be the cosine of x dx. So if I integrate that, that's sine of x. And so this becomes uv 3 to the x sine x minus the integral of v du. So that's ln 3. Yes, ln 3 to the x sine x dx. Did I get everything there? Sine of x, 3 to the x dx, and the ln 3. Yes. Okay. And so now I'm going to do for this thing the uv again. So if I let u be 3 to the x again, du would be ln 3 times 3 to the x dx. And if I let dv be sine of x dx, this would be negative cosine x. The derivatives in my second row here. So now we get what we started with. Is equal to 3 to the x sine x minus ln 3 times 3 to the x times a negative cosine x minus these two, which is going to be a minus ln 3 integral, and now I got to get all of them, 3 to the x, I got the ln 3 already, 3 to the x cosine x, I took the minus out with the ln, and dx. And this looks like what we started with. So I just got to find out how many we got here by doing the distributions here. So I get 3 to the x sine x. This is all equal to integral of 3 to the x cosine x dx. Minus times a minus is plus ln 3 times 3 to the x cosine x, and then minus ln 3 times, and this is minus a minus, which is plus, so we're going to have minus ln of 3 quantity squared. And then we got to do times the rest of this, which is the integral of 3 to the x cosine x dx. So I'm going to subtract these, actually add these to this side. So I have one of them plus ln 3 squared of them over here. So I got 1 plus ln 3 squared, that many of the integrals 3 to the x cosine x dx equal to 3 to the x sine x plus ln 3 times 3 to the x cosine x. So if I divide by that, I have what this is equal to, plus c. And finally, 45. Some of you thought this one was going to be pretty hard because you had ln of x and had no idea what. Let's just do the simple substitution to start with. U equals ln x du equals 1 over x dx. So x du equals dx if you multiply both sides by x. So this becomes the integral of ln u times u over x, and dx is x du, and the x's cancel. So now we have the integral of ln u times u du. And we're going to integrate by parts. Now, usually, we let what will get simpler if we take the derivative be u in the uv thing. Kind of got two u's going here, but we'll try to keep it straight here. We could call it wx or something, wv or wz or something. Anyway, but when you have ln, it's kind of hard to take the integral of ln of u. I'm not sure what that is, but we can take the derivative. So we're going to put ln u here. And so du would be 1 over u du. And so we're going to put the u du down here and integrate it, be 1/2 u squared. So following the integration by parts rule, this would become uv 1/2 u squared ln minus the integral of, we started with those two, so we're going to these two, of 1/2 u squared times 1 over u du. Well, that u will cancel one of those, so we just got the integral of u times 1/2. So this becomes 1/2 u squared ln u minus 1/2, and the integral of u du is u squared over 2, and there'll be a plus c, but we'll change that. So now we'll put back ln x in for the u, so we got 1/2 ln x quantity squared ln of ln x minus 1/4 u squared, so that's going to be ln of x quantity squared, so that's in both of these. So we could actually factor out 1/2 ln x. That would leave a 2 here, but that's probably what they did in the book, but we're not going to worry about that. Plus c. Maybe I will do it. If you took out a 1/4 ln x quantity squared out of this 1/2, the half would be gone, the ln x would be squared, so we'd have ln of ln of x minus 1/2 times 1/2 would be 1/4. We took out this, and so that would be all we have there, plus c. And that should do it.